Hey, good afternoon. How's everybody?
Good afternoon, Professor.
How are you? How's everybody else? Nobody's greeting, huh? Just one person. Um,
Good afternoon, Professor.
how are you, Mohammed? How are you, Ravina?
Good, how are you?
I'm good. I'm good. Um, I believe you guys have. Well, of course, most of everybody submitted quiz one, and as I've been telling you, quiz one is the uh, first test that will be, 20% of, they will count as 20% of your grade, okay? And the result is, the exam is still visible, and you can review your, result. Um, what I want, but, I hope you may have also, I hope you have also noticed the summary statistic, okay? The summary statistics. Let me share my screen. Okay, so if you go to the assignments, okay, this one is still visible. Still, quiz one is still visible. The rest of them are not visible. And we have already quiz one review there. Um, if you play these videos, I mean, they are like 1 hour long. I went over not every problem because, obviously it takes a lot of time. So I went over certain problems that, but this is, based on the past semester. This was like recorded already, like in fall 2020 or uh, spring 2021 or fall 2020. So, okay, that was, when did we go, um, when did we go online? Was it spring 2019, I believe. Spring 2019. So it's been more than 2 years, spring 2019. I mean, it's uh, slightly over 2 years. Was it 2020 or 2019? I mean, the new this is the new normal, right? College has gone online, I believe. Uh, so anyway, so please, if you have further questions, watch these videos. And then this is whatever is gray, you don't have to bother with that because you can't see them. This one, oh no, I don't need to download that. But if you click on it, you'll be downloading that file, and that file is actually, this is, basically it's so, this is your, it's listed by your student ID, and these are what you have earned, right, during the class. I mean, attendance and participation points. Um, that's the total of what you have. Okay. There is someone who has earned, like, very pretty decent, like 12.5. That's already a lot. And then you go to data analysis, and it's sorted by weighted average, right? Weighted average. And the weighted and these are okay. I don't need to put. It's always obvious. It's already obvious. Again, ROI concept check and ROI practice, they don't count. They don't factor into the weighted average. If you look into weighted average, you can see, you will see what it means. It's exactly, it's exactly calculated the way it is supposed to be calculated, right? 20% of quiz one, right? And that's D2. F2 is quiz 2. So they both 20% of the sum of these two. And then midterm and final, 25%, right? Midterm and final. And the H2, column H is, attendance and participation. So it is sorted, right? So that's weighted average. And of course, as we get this data, right? Currently, these three data sets are not there yet because you haven't done it yet, right? But as you submit these tests, and they will become, we have only like this weekend the next. I mean, think about it. We have today is so this weekend the next. So over these 2 weeks, I have to give you these 3 exams, right? So it will be a pretty, busy, busy 2 weeks, right? And as we get these results, then the weighted average will change because, whatever numbers are, whatever data value come in here, right? This will change, and it will be again sorted again. I mean, currently 29.30 is the highest weighted average. Currently, mean of the weighted average is this. Standard deviation is 7, so 18.71 plus 7 is almost like 19 plus 7, so 25. Roughly about 25. If you are like, 1 standard deviation above the mean, that's pretty much, safe range for A. I mean, it's just at this point, rough estimate. It will change because, mean and the standard deviation will change as I get more data. But for now, I'm just giving you some criteria, how the grading is in my class, how the grading is done. It's basically, normal distribution of follow. It's curved. Grades are distributed along by a normal distribution curve. So if you're around the mean, let's say about here, but again, we don't have, that's 75% of the data. Look, this is only 20% of the data. Attendance is 10%. So together with this and 10%, that's 30%. The remaining, this is remaining 70%. So as the 70% can, it can swing the direction, right? It can swing the direction the other way. I mean, currently, this is the highest. I mean, this person is the highest, but depending on how you all do, this ranking will change. Ranking will change. So the way I grade is, basically based on the, it's statistical. It's based on the mean and the standard deviation. I just said a while ago, roughly one standard deviation above mean is like a cutoff point for A. It could be 1.25 standard deviation above mean, depending on, depending on the mean and the standard deviation. I mean, if the standard deviation is rather small, then I could use 1.25 standard deviation. And if you're around mean, think about it. Mean, if you're around mean, that means you deserve, like, you belong to the median grade range, right? Think about it. There are like 9 letter grades, A through D minus, and that's all, it's like 9 grades: A minus, B plus, B minus. I mean, between B and D, there are 3 grades, 3 further classification in each grade. So B, C, D, that's 3 times 3, that's 9 already, right? 9. And A minus, so that's 11. So the median would be like B minus. So again, there is a range for B minus, which will include, which will be centered around the mean. So something like, 0.25 standard deviation around the mean, right? So if you're around here, that would be like, B minus. But again, and if you're like 1 standard deviation below mean, 7 below this is like 11. If you're like, below 11, that's F. Okay. Luckily, there is nobody currently. Again, only 2 people are below there, but these people have submitted nothing. As you can see, there is no record of whatsoever, right? So if you are, but it looks like they have been attending. At least that means 2 presents, right? 0.5 is just 2 days of 2 present days, 2 present classes. This person has more than, but then no record of whatsoever. So these 2 people better watch out and be very keen and alert and keen on these remaining exams. Otherwise, this is guaranteed F, right? Again, the whole scale will move up as I get more data, right? This currently, the way it is not definitive at all. It's not definitive at all, right? You can't, because we are still lacking 70% of the data, right? Does that make sense? Any questions? Any questions? Okay, I really should get a like dual monitor.
When will the next quiz be?
It will be midterm, and after we cover topic 3. After we finish topic 3. Of course, topic 3 is already finished, actually. If you think about it, I've been telling you over and over, collaborate session is not the lecture. It's not the collaborate session is not the original lecture. It's only a reflection or aftermath, right? You know what aftermath is. reflection, or aftermath. Actually, third topic, time value of money, this was already finished, right? As of last week. This was so we are actually currently we are in so I can give you I mean the midterm is already it's time for actually it's in order. It's the midterm is in order. Today actually this is the original lecture for today. Why this is not showing, but okay. So we should be already talking about bond valuation, and you should be caught up all the way. This is basically today's videos, today's lecture. You should be caught up with all the way up to this point. You should be caught up completely up to this. So the midterm is completely midterm is all about this. Okay, time value of money, and so I'm thinking of making it. Okay, I gotta make it of. So it will be sometime this week. It will be sometime this week. Okay, it will be. Let's say. It will be too late. Maybe not too late. This weekend, I will give you again, like 3-day window. You'll have about, 120 minutes or 180 minutes, depending on. I will check because it's already built in there. I will see. I will check. It could be 120. So it will be this weekend, and I will give you like again 3-day window, and you can pick your the most convenient or most convenient 2-hour time frame that you're at your best condition, best mental and physical condition. And then that means I will have to squeeze in. Then the next week, that means the whole week next week I will have to squeeze in because the last day of class is the 19th, and the final I will have to report. The grade report is always within 48 hours. So then the final will have just 2 days, 2-day window. I don't know. Maybe I will just use. I will assign quiz 2 for 16th and 17th, 2-day window, or 18th, and for final 19th, 2021, 3-day window. And still, I have to. That means I have to finish grading and report. Submit the grade report to the registrar by 11:59, the 21st. Okay. So it won't be that everything is within the next 2 weeks. Okay. So again, you should be I'm telling you, this is today's lecture. Okay, don't rely on the collaborate. Collaborate is only like a reflection.
Wait, after
right?
midterm is quiz 3, right?
Quiz 2.
Quiz 2, and that will be on topic 4.
It will be no, not just topic 4, 4 and 5.
All right, 4 and 5. Got you.
It will be like 4 and 5, and final will be on 6 and 7. Okay, so it's crunch time, really. Next you know next 2 weeks. I mean, including this week. Uh, this upcoming 2 weeks, it's really crunch time. Okay. All righty. So, okay, someone says Ophelia. Okay, what does that mean? Ophelia, you said no. I mean, in the chat box, what does that mean? No to what?
When you were asking if there's any questions, you said no.
Oh, okay. All righty. Thank you. I mean, thank you for clarification. Okay. All righty. Any questions? I don't, look, it's gonna be really, I don't know. This whole week may be spent on most likely this whole week will be spent on time value of money, and it's gonna be really. I just hope it can be done in a better way. But as I said, this one is already it's already done, right? The original lectures were already done, and if you have missed, I've been telling you, it's in the uh, it's on YouTube, right? Everything that you have missed, there's everything without any time restriction, right? Without any time restriction, it's here. Okay. All right. I just want to so this is the this is the PDF file you will find in the that's the PDF file you will find here, and the time value of money XL, right? That is the file you will find. I'm gonna. This is the same file, but this one was used already in another class. So I'm gonna open. Okay, I'm gonna close this. Alrighty, I really need dual monitors, and I think I need extension of my monitor. This laptop I have has I don't know. This is 14-inch screen or 15-inch screen. I don't know, but even if it is just not, I don't need a big screen, but I need multiple, monitors. So this is why, because I have to open a lot of windows all at the same time, and that is really a pain. Just relying on a single monitor. Alrighty, so this is very basic. Some people may already know the basic concept, but I do it strictly with I do it by Excel strictly because, and also it's soft coding through soft coding, and you will see what I'm talking about because it can be it's all about architectural, structural design of the architecture. Okay, so let's think about it. Suppose you have you put $10,000 in a bank and the interest rate is 10%, right? So how do I express that? That's principal, right? Or P0, it doesn't matter, whatever you call it. Of course, it's dollars, right? 10K. You put it in a bank, so it's principal, right? And then interest rate, R, you remember, R is a generic notation for a rate of return. But again, it also means real return, right? Real return, and I would be nominal return or nominal interest rate. But let's forget about it. Just it's a generic notation for return. Let's say it's 10%. Interest rate is 10%. Time. Let's first assume you put it for 1 year. And time isn't, let's say, in years, 1 year. But of course, we can assume 2 or 3, even, all the way up to 10 years or even more. Even longer. So let's call it N for N years or N periods, right? Then our question is, okay, just 1 year later, right? Just 1 year later, what's going to be there 1 year later? We all know, I mean, it's easy enough. It's, 11K. There's going to be 11K. There's going to be 11K. That's called future value at the end of year 1. And we know it's 11K. Why? Because it's easy enough. There is, principal of 10K. We already know it's 11K, but it's the analytical mind, the mind that can analyze, that is, very, that's priceless, right? The mind, the brain that can analyze. So where did this? So how did we come to this 11K? Oh well, that's of course principal of 10K, and then 10% interest of 10K, which is 1K. But 1K is basically what? 10K. No, what?
The 1K was
10%
the
of
interest.
10,000 is 1,000.
Yeah. So don't give it in words, right? As I said, analytical
1K
mind is
high.
10. It's 10K times 10% or 10K times 0.1. Isn't it right? That 1K is, how did you arrive at, 1K? Is 10K, actually, right? If you think about it, is 10K times 0.1 or 10%, right? Times 1 year, right? You see what that one is? It's for 1 year, right? Of course, then that's, 1K. Right? So that's how that 11K came about. But then again, I can represent it also as, because 10K is P, right? That's P plus P times R times T. Isn't that right? Isn't that right? It's P
Yes.
times P plus P times R times T. Thank you for confirming that. And we know this is not a very good, this is not very good way of writing it. Why? Because there are, two terms with a common factor, and having the common factors, lying around like that, that's not a good form. I've been telling you about this, eliminating redundancy, right? And I've been talking about this all the time. You don't leave it like that. You factor out the common factor, right? Remember, redundancy is the pariah, right? You cannot. In spoken language is inevitable, but I've been telling you, in written language, it has to be concise, right? You don't repeat the same thing over and over again, right? So you factor out. Didn't I give you the example of John goes to BMCC and his sister Sally goes to BMCC and I go to BMCC? Didn't I give you that example? How it is not a good form, a good sentence in written language? Is this the first time I mentioned that? Come on.
You mentioned it before.
Yeah, of course. Thank you. So we have to, now you understand, we have to factor out the common factor, right? So if you factor out the common factor, then it's P times 1 plus R. And you might wonder, what happened to T? Well, T is 1. It's 1 year, so we don't have to write it, right? So then what about year 2? What's going to be the future value in year 2? In year 2, okay, let's skip the numbers and get straight to the algebra. So at the beginning of year 2, what is sitting there in our account? Well, at the beginning of year 1, there was principal, right, sitting there. But at the beginning of year 2, what is sitting there?
11,000.
Yeah, what is 11,000?
the amount from
What is it?
the previous year, so P1 plus the interest that you received?
Yes, yes. Yeah, that's true. 11,000 is P times 1 plus R. That's true. That's 11,000. It's the result. Also, 11th, what's another name for 11,000? This is such a plain common sense thing, but it's right in your eyes. But you guys don't realize the importance and
The
usefulness of the, huh?
The principle of future valuation too is 11,000.
Yes, that's right. That's right. But then, so what is 11,000 is like the principal in year at the beginning of year two. But it's got a name. What is the name?
11K.
No, no.
Future value?
11K has a name. Huh?
Future value?
Yeah.
Year one?
Just future value. Just future value. I mean, you're at the beginning
Future
of
value
year
in
two.
year one?
Yes, that's right. That's what I've been trying to emphasize. It's plain. It's right in your eyes. It's plain, but you don't realize the importance and usefulness of equal sign, because what equal sign means, this is equal to this. 11K is equal to this. That means 11K is future value 1. Isn't it right? And then it's equal to 10K plus 10K times 10% times 1. I mean, follow the equal sign. Equal sign is telling you this is this. A is B, which is equal to C. That means B is C, which then C is D. So you can like substitute all of these. So at the beginning of year 2, future value 1 is sitting there. Isn't it right? And then that future value 1 this is very important, because I mean the role of the role that equal sign plays, because in another class, which is Business 210, which is basically algebraic modeling of business problems, students don't realize what equal sign means. Because if you're saying future value is equal to something, then you have to stick to that. If you're in the cell that is designated as future value, in the cell, it is designated as future value. How? Because the label on top, label in the first row, top row of the table says future value, and in the cell it should be the future value, nothing else. And then some people don't. And then in the first row, in the first problem they do it, they follow it. Then from the second row, then they all go into chaos. If the label says future value, it should be future value, through and through, row after row. But then they are forgetting that if the label says future value, in that column it has to be consistently future value. They forget that, and then they put anything randomly, and this is total lack of structural organization. It has to be a neatly organized structure. So it's the architecture of the structure is very important. And if you to be able to do that, you must have a systematic thinking. A lot of people lack that systematic thinking. So see how systematic and methodical this is. So at the beginning of year 2, you have future value 1 sitting there, and it's going to earn again right? 10% for 1 year. Isn't that right? Which is called interest, of course, right? Which is called interest. And then by the same analogy, you can factor out the common factor. And if you factor out the common factor, that's going to be FV1 times 1 plus R. I believe we did this at the, in ROI. You see, and then, because you factored out FV1, right? It should be 1, right? And then what is FV1? What is FV1? What is FV1?
11,000.
No. Don't give me the number. What is the definition? What is the logic? Huh?
Face value at year 1.
No. Don't give me the word. Don't give me the words. I've been telling you. Forget the words. Use math as the language. So how is FV1 defined?
It's the beginning of future value 2.
No, I told you to forget the words. Don't give me the word. Verbal definition is, not needed. Speak in math. What is FV1?
P times 1 plus R.
Yeah. And who was that? Who was that?
Inyu.
Inyu. Okay. Inyu. All right, Inyu, you got 0.25 for that. Today is 8:09:08. Okay. Yes, the definition of, look, FV1 is equal to this, P times 1 plus R. So simply replace FV1 by its own definition, then we get P times 1 plus R times another 1 plus R. Right? You get the idea? Because we simply replaced FV1 by its own definition, right? We replaced it by its own definition, right? But again, we know this is not the most compact, concise way of writing that. So what's the better way of writing that? The better way of writing that is, we already know. Anybody?
P times 1 plus R squared.
Square. Okay. And who was that?
Inyu.
Okay, Inyu again. Another 0.25. Now, then try FV3. Let's try FV3. That's the future value at the end of year 3, right? Again, what is sitting there at the beginning of year 3? What is sitting there in your account at the beginning of year 3? What is sitting there?
The future value.
Yes. Yes, you're right. Who gave me that?
Mohammed.
Mohammed. Okay, Mohammed, you get, you get 0.25, Mohammed. Yes, you get, future value 2. And you earn interest again for 1 year, which is, FV2. So hard. Which is, FV2 times R times 1. So I don't write 1 because it is, you don't have to write 1. That doesn't look like, you know, R. It looks more like gamma, but you know, this. And we know we can do better. We factor out the common factor, which is, you know, FV2, and then time. Why is it so? It's really it. Your hand gets also very tired, you know, doing this, and, and it's control. It's mainly, you know, control. It's you know, precision. It's almost like your wrist, especially. It's the wrist control of your wrist. So then, again, we know what is the definition of FV2. What's the definition of FV2? We don't leave it like this. What's the definition of FV2?
P times 1 plus R
Mhm.
squared.
Yes, P times 1 plus R squared. And who said that?
Mohammed.
Mohammed again. Okay, so Mohammed, you got another 0.25. Is P times 1 plus R squared. And I simply replace this by this, right? So, and then I have 1 plus R there again. So finally, I arrive at, so this is not the best way to write it. So what is the best way to write it? Anyone?
P times 1 plus R cubed.
Yeah, P times 1 plus R cubed. Okay, so extending this logic, right? We can do anything. I mean, we can do, like, you know, we can find a future value at the end of year 3. Future value at the end of year 3. Okay, and then we come to the, you know, generalized, you know, we come to the generalization that of not 3, but you know, what is this? N, right? Future value at the end of year n is, you know, can be found by P times 1 plus R raised to the nth power. So this is the this is called compounding, right? Because your, you know, future value is the result of the interest rate being compounded over and over, right? So let's try that with our, you know, let's try that in Excel, because I have, you must have this already, you know, opened in front of you. Do you have this file in front of you?
Professor,
You have this? Yeah.
I had a question really quick. For the FEN that you had just put up, what was the N meaning again? What does the N mean?
N simply means number, any number, any number.
Oh, okay, so it's just a general term.
Yeah, yeah.
Okay.
It's just the general notation, right? Or rather, generic notation, right? Generic notation. So, okay, so let's think about, oops. So do you have this file in front of you? Everyone?
Yes.
Okay,
Yes.
good.
Yes.
All righty. All righty. So let me, no. Then if you have it, just delete all the highlighted cells. Delete all the highlighted cells. Okay, delete all the highlighted cells. And let's change the principal to 10,000 to match our example. Also change the APR to 10%. Now, if you wonder what is APR, that's simply in annual interest rate, right? Because it means annual percentage rate, annual percentage rate. So you might wonder how. So what's the difference? I mean, why don't we? Isn't that R? Yes, it's rate, but R is also a generic notation. R can be not. R can represent not just annual rate. It can represent monthly rate, or quarterly rate, or daily rate. It's R would be a generic notation, and T number of years, right? And this is future value, of course. So M, forget about M for now. You don't have to worry about M for now, but it's so then let's try. Okay. So what's going to be the future value at the end of year 10? Okay. So then all you need to do is simply, look, it says the label is future value. So future value is equal to, it's equal to, right? That's what it means. Principal, which is in, you don't have to, principal is here. You don't have to manually input 10,000. You simply, with your mouse, you can just click it in. You just click it in. Times, you have to put times, because without times, we don't use times when we, write it. We don't use times, but everyone knows times is just, omitted. We don't put times. We don't have to put times in algebra. But, when you enter it, when you put it into Excel, Excel doesn't know that. There must be a verb. You understand? There must be a verb, right? What is the verb? Multiply. That's the verb. In other words, there's the operational. There must be an operational Q. You understand? For Excel. So without the multiplication, it's not going to work. So you have to always do this, and then 1 plus R, right, raised to, this is N, right, and voila. Okay, and then that this is called, there's a name for that. It's called carrot, right? Not the not the red carrot, not the legume, the carrot, like the carrot that you nibble on for, diet, I mean, if you're on vegetarian diet, and you don't, as your snack, you eat this carrot, right? It's also pronounced like, carrot in diamond, right? But it's actually spelled C-A-R-E-T, so it's a different thing. That carrot comes from French word carré, which means square. But this, sometimes people say, hat or cone sign or hat sign, but that is the universal machine language for raising something to power. And this isn't totally, unfamiliar, because we did this, right, early on, when we were talking about a return on investment. So if you hit enter, yes, this is going to be the result of compounding 10% interest, 10% interest rate for 10 years. Next question is then, what is this M? What is this M? M is compounding frequency per year. Compounding frequency per year. Okay, so that means compounding doesn't have to be necessarily just once a year. Okay, the compounding frequency can be M can be either 1 or 2 or 4 or 12 or 52 or 365. Was someone trying to say something to me? Because I heard some noise, like the radio breaking, silence, some radio noise, static noise. But you gotta understand, I can't hear you unless you have a good. Safia, are you okay? Because it looks like you are connected through phone, but
Yes,
I
I'm okay.
see, okay, good, because yeah, I can tell, your activity status, it's pretty good, but I heard some, like static noise. And also you can tell because when you okay, and I cannot see this, because I'm when I'm unless I have like dual monitors, I wouldn't be able to see that when I'm looking at my Excel. Okay. All right. I gotta give my throat a break. Oh, it's really hard. So anyway, so think about it. If the what did I say M is? Anybody can tell me what did I say M?
The compounding
What did I
frequency
say?
per year.
Yeah, it's compounding frequency per year, right? So why is it M then? Shouldn't it be F or well, M stands for something like multiple times, right? Compounding can happen multiple times. If it is 1, it's just once a year. If it is 2, it's twice a year, which is called, semi-annual. Semi-annual. Okay? Semi-annual is every 6 months, but people, this is the interesting thing. Some people don't think, if it is, semi-annual, they think M is 6. Because it's, each 6-month segment, it's like semesters. But then think about it. Then compounding it's not 6. It has to be 2, because there are only 2 semesters in a year. And some people think this is 6. And what does that mean? Then that's bi-monthly. If M is 6, that's bi-monthly, and that kind of frequency is possible, but it's not normally used. Okay. If M is 4, is quarterly compounding every quarter. If M is 12,
Every month.
of course, it's monthly, right? If M is 52, it's weekly, but it's
Every week.
theoretically possible. It's theoretically possible. In reality, they hardly use weekly compounding, right? And if M is 365,
Every day.
yeah, daily compounding, right? And you might wonder, is there compounding frequency greater than 365? Yes. But it's only for theoretical purpose, right? In other words, theoretical means mathematical, right? Purpose. And people, most of the students think, they associate the word theoretical with a lot of verbiage. No, in economics, finance, physics, math, theory is all mathematical. You understand? You don't use words. If it has a lot of words, that's simply it's looked down on, right? That means if you don't, if it is full of words, then that means there's no substance. There's no substance because the best the best uh, best dissertation, best paper. Good papers are always, good papers in, physics, economics, math. Um, good papers, uh, finance, statistics, math, physics. They are not hundreds of pages. Good paper or good paper, good thesis is no more than 25 pages. Why? Then that means the it should have minimal verbiage. Everything must be condensed. And how do you condense it? Mathematical expressions are condensed statements, right? Mathematical expressions are condensed statements. One equation is worth 1,000 words. Okay? So that's why, any thesis that is full of verbiage, they don't even read it. They throw it away. They just, it's rubbish because, in economics, finance, math, physics, statistics, if you use words, it's just inefficient, waste of time. It's pariah. They look down on it. Words are rubbish because it takes 1,000 words, but it will take only one equation, one simple equation to explain a profound concept that can only be described by thousands of words. Still, thousands of words, it takes so much time. Who has time to read 1,000 words? It's really, one equation that sums up everything. It's so compact and condensed, it explains everything in just a single equation. Simple single equation. That's what is, powerful. That's what, the power is. What is powerful doesn't have to be full of verbiage, right? Without speaking too many words, just one statement, and if it changes everything, that's powerful. Isn't that right? That's the power of math. So, and I don't know if you, I don't know how many of you ever saw the movie The Beautiful Mind. That movie came out in, I believe, early 2000, which is a movie about a famed economist, Nobel laureate. Suddenly his name escapes me. Such a famous.
Is it Nash?
Yeah, John Nash. John Nash. Yeah. Who said that? Who said that?
Cool.
Abul? Yeah, Abul. You deserve 0.25 for that. John Nash is a very, um, he was a genius, but I don't know if he was, if he really uh, lost his mind or if it was CIA plot, but um, or if it was, everything was, he was just hallucinating or whatever. But John Nash was a Princeton educated economist back in the 40s, and during the World War II, he worked for the U.S. Government. Maybe uh, I don't know whether it was Department of Defense or whether it was CIA. But then in around 1960s, after World War II, and he was suddenly, I mean, he had this mental disorder, uh, and he was teaching in no, maybe not in Princeton, but Yale or Harvard, or MIT. But because of that, obviously, they all thought he was crazy. So he lost his job, he lost his teaching position, but then he lived, he went back to Princeton. I mean, not no position, nothing was offered because he was already labeled, he was already labeled as psycho. Um, then mentally insane. Then he just lived his life, during the 70s and 80s. He just, as Princeton alumnus, he was able to access, Princeton, library, and he did mostly, he was immersed himself, and he did only, research, and he developed, he wrote this, dissertation about, game theory, and for that he was awarded, Nobel Prize in Economics in 1990 something, and he was honored as a fellow at Princeton. I mean, he didn't really teach, while he was, just um, immersed himself and doing only the research at Princeton. He helped out like a mentor. He helped out, Princeton students. Um, because now nobody would offer a teaching position to a mentally insane person. But whether it was, CIA plot or, whether he was really mentally insane, uh, it's still a moot point. But the thing is, his dissertation, his doctoral dissertation consisted of only like 20 pages. You understand? A doctoral dissertation, people generally think it would be like hundreds of pages, 500 pages of this. No, in economics, physics, math, finance, anything that is based on math, they consider that a rubbish because it doesn't need to have thousands of words. The theory can be represented, expressed by a single equation and a couple of more, mathematical expressions that just support that equation and some proof of that equation. That's it. Minimal verbiage. That's what the geniuses do. Geniuses don't use words. Geniuses speak in math. Einstein, the gist of his, theory is all math, mathematical equation, a single mathematical equation. he doesn't put it into colorful words, right? Colorful words only refer to, it only means, I mean, of course, being, if it is efficient, you don't need colorful words, but if colorful words are needed, and if it increases efficiency, yes, true, fine. Poetries can become more powerful and more condensed by using colorful words. But with no good reason, if you use a lot of colorful words, that simply means you are void. You don't have substance. What you speak has no substance. You just have words that are very floral, right? Flowery words, but empty, hollow, void, minimal substance. And that's why, that's the difference between science and art, liberal arts, humanities. So, humanities, like, literature, sociology, history, so just full of words. Because, and then think about it, history books, hundreds of pages full of words, but, all these accounts vary by the author. I mean, the same event, so many different interpretations. I mean, you might find value in it because, it may be interesting to read different different accounts, which are different interpretations of the same event, same historical event. But then, what is the truth? I mean, if there are so many different accounts, different interpretations, what is the truth? There can be only one truth. But what is the truth? Does the truth vary depending on different perspectives? Different perspectives are only interpretation, right? It's only different interpretations. But the truth is one thing. I mean, about, Nazism and Hitler. There can be many different interpretations, but the truth is, the fact is, the truth of the matter is that Hitler and Nazism were evil. They inflicted so much, so many war crimes and atrocities, crimes against humanity. That's just the fact. It's that's the truth. There can be no dispute, no denying, no argument about it. Although there can be many different interpretations depending on how you look at it. But then many different interpretations are not truth. But there's no such thing in science, right? Everything, there can be different interpretations, but they all point to the same thing. They all point to the same thing. That's science, right? They don't point to different things. And that's why math is important and math is powerful, because you don't blur, because all these different interpretations in historical events, they blur the eyes of the people. I mean, reading, depending on how, whose interpretation you read it, you are blinded by it. You're affected by it. But then that's not, there's no, in math, there's no blurring of truth. Math is, Math is really trying to speak about the truth in exactly in the way it is, exactly the way it is, nothing else. It clarifies everything. So you need to speak in math, and you need to make a habit of that. Okay, it should be in your bloodstream. It should be your second nature. Okay, so we were talking about the compounding frequency, right? So here, in this second example, it's the same scenario, right? Same initial input data is $10,000, 10%, 10 years. But the compounding is 4 times a year, it's quarterly compounding. Then we need to we need to uh, we need to rethink how we are going to find the future value. Well, first, if compounding happens every quarter, then what is the rate? What is the interest rate that actually applies each quarter? Well, it's obvious. It's 10% divided by 4, so it's going to be 2.5% every quarter, right? And then since there are 4 compoundings each year over a 10-year period, how many compoundings? How many compoundings are there going to be? There will be 40 compoundings. Isn't that right? That is explained by this. That is explained by this equation. Look, future value is principal times 1 plus APR divided by M, right? So it's going to give you 2.5% raised to M times T, or T times M, M times T, right? That's going to give you 40 quarters. Does that make sense? Does that make sense, everyone?
Yes.
Okay.
Yes.
Okay, thank
Yes,
you
Professor.
all right, thank you for the confirmation. So all we need to do is simply, okay, we'll make adjustments. So P times 1 plus APR divided by M. So this is called soft coding, right? You have separate table for data. You have separate, right, cells for data. And then in the formula, you don't manually input that number. You don't enter the number. The data, that numerical data is there. You only click it in, and that way, you can replicate it over and over, in under different setting, right? On the different setting is simply change the input data, and it's going to automatically the formula is going to automatically adapt to new input data. So that raised to T times M. Okay. Now you gotta enclose that in the parenthesis, because otherwise, if you don't put it in the parenthesis, what's gonna happen? This thing, right? This thing will be raised to C3 first. If you don't put that in the parenthesis, it's going to be raised to C3, and the product of that, the result of that, will be multiplied by D3. So it's going to be a completely different thing. So you got to enclose it in the parenthesis. It's called PEMDAS, right? PEMDAS. It's basically, it's an acronym. If you went to, K through 12, if you went to a school in other countries, probably PEMDAS already. You just don't know it is called PEMDAS, but that's just what it is called in the US. It's simply parenthesis, exponent, multiplication, division, addition, and subtraction. It goes by that order, right? So it's nothing. but everyone already knows this. In other countries, that they all follow this rule. Math is universal. But whether they have name for that or not, in other countries they don't have the name. Probably in some countries they call it the order of operation. The order of operation. It has to, but in the U.S. it's called PEMDAS. Okay, there you go. I got this. So obviously you can tell. Oh, the same principle, same interest rate, same number of years, but the more the compounding frequency, the greater the future value, right? Because as there's more compounding. And also, I can copy and just, paste it over here. Okay, I can copy and paste it over here. So here, what do you see? Oh, it wasn't what I entered previously. It wasn't what I entered there previously, but because, of course not, it wasn't. And I copied this and pasted it here. So the formula is, replicated, right? Exactly this way. But in this case, since m is 1, I mean, there's no harm. I mean, look, when compounding is once a year, annual compounding, you can use this formula. You can use this tweaked formula, and there's no harm. It's harmless. It's innocuous. Why? Because 1 doesn't affect anything. But then, why do we do it that way? At least, that way we can retain the consistency, consistent uniformity, right? We maintain consistency in uniformity. It has to be uniform, right? And normally, after I do that, I use, I put it under, oops, what? I give it thick outside border. Okay, what I do? Let me use. And what else? Thick border, right, that way. Okay, can put a thick border around it. So this one. Now, on the next one, it's the same scenario, right? 10,000, 10%, 10 years, and quarterly compounding. Here, what am I trying to do? Again, I'm trying to, what I'm trying to do is, I'm trying to, instead of, making this adjustment inside the formula, right? I'm trying to make that adjustment to R and N outside the formula. In other words, remember, R is, I've been telling you, R is the generic notation for rate, and N is the generic notation for time periods. So it's called a periodic rate. Periodic means, for each compounding period. So if compounding is quarterly, that means, for a quarterly compounding period, then the rate will be, periodic rate will be simply that divided by this. Okay, and then N is the total number of compounding periods, right? Of course, it's going to be 10. We all know that. I mean 40. It's going to be 40, right? So this way, the formula can be simpler, right? Formula can. So all you need to do is simply P times 1 plus r. This is the r, not 10% raised to, because it's already the result of this raised to, right? N. Okay, that way we get the same result, but it's simpler. So when something goes wrong, for example, if you have a complex formula for solution, and when something goes wrong, it takes more time to fix that error, right? Think about it. If your system is simpler, it's easier to identify the source of the error, and it's easier to identify it's easier to fix it, because um, if the system is complex, right? Even detecting the source of the glitch, it will be very difficult. I mean, think about your disassembling, or if breaking down an engine, right? If this, and obviously it will take a lot of time, and to we don't know what is the your car has a problem. You think it is the engine. Of course, you take it to a mechanic. Mechanic will diagnose it, and they will know. Of course, with the diagnostic tools, instruments, they will know whether the problem is with the engine, or with the fuel system, or with the electrical system. But if it is mechanical, I mean, whatever it is, I mean, so let's say the problem is with the engine, but it's hard to tell where the problem is coming from. Then you'll have to completely tear down, or you'll have to completely pull down, or what's the word, break down the engine, just to look into, and then it takes a lot of time, right? You understand? If the system is more complex, right? But if the system is simpler, and let's say the engine is not a big chunk, but the engine is not a big one single hunk, but let's say it is more like a connection of three parts. Well, you can easily, I mean, if looking into the engine is easier, right? And then it's also easier to detect whether the problem was from here or from here. And without even touching the main engine, you can, fix it from here, and everything will be, automatically fixed, right? So that is the main benefit of simpler model. And let me again, let me give it a few more. I'm gonna have to. Okay, let me. So the interesting thing is we can think about any. Okay, so how about this time? Enter any 12 years. This is semi-annual compound, right? And then if there are like, if you have to do like 10 problems like this, you have to do 10 problems like this. Let's see, years. And then always use 2 decimal places, at least 2 to 3 decimal places to make sure that it's not just unnecessarily rounding too much. And let's say 25 years. That looks like mortgage, some kind of mortgage. Okay, let's try. And then like 6%, 5.75% for 20 years or 20 years, yeah, like bond, long-term bond. And bonds are, right? And also, and then 9%, let's say 9%. 7 years. Quarterly compounding. Look, I don't have to do any further, but you know what I'm trying to say. All these problems previously without Excel, you have to do it manually one by one. Every problem has to be solved, and every problem has to be solved anew. Each problem you solve it manually, anew. If you do it on Excel, all you need to do is just copy those and drag it down, and you get, right? This is the structural efficiency. Okay, this is the structural efficiency. Because you're doing it, systematically, right? And you have to think about the architectural. I mean, this is my architecture. I mean, you can have a different architecture, but the point is, there has to be some, uniformity, right? Consistent uniformity, right? If it isn't uniform, right, then you can't reapply. You cannot recycle or reuse the same structure over and over again. But if you have a unified structure, right? I mean, the problems are generally, principal is this, interest rate is this, time is this, maturity is this. This is the compounding frequency. What's going to be the future value? And then, of course, you do it, it's not a difficult thing. And you can do this in, just 2 seconds. It doesn't take more than 2 seconds, right? Once you have, now I had to think about the input data. I had to make up input data, but initial input data was already there. If the initial input data was there, then it's done. And if the initial input data can be downloaded, it can be done in just 2 seconds, right? Okay, so this is, compounding, right? Example of compounding. All righty. And let's think about this example. Now, the reverse process of compounding is called discounting. Now, reverse process is like, the concept is like this. So, you have certain target future value. In other words, you want to put your, in 10 years, you want to have 25, almost, that's 26, 25, 9, 37 in 10 years. And currently the interest rate is 10%. Then the question is, assuming, just a single annual compounding, what do you, what do you need to put into the bank today if the prevailing market rate is 10%? And if this is your timeline is 10 years. In other words, you want to have this target future value, right? This is your target amount. You want to have this in 10 years. How much do you need to put into the bank today? So
10,000.
How do we find that? It's the reverse process. Actually, no, think about it. It's the reverse process of compounding. Why? Now think about it. We all know, and I've been telling you over and over, a key to solving any equation, no matter how complex, key to solving any equation is identifying z equals x times y structure. All right? If you can identify z equals x times y structure, and usually it is written this way because z is the unknown, right? Usually z is the unknown. But if z is known, if z is already known, then what does that mean? Either x is the unknown or y is the unknown. Isn't that right? And suppose, y is known, then x is the unknown. How do you solve for x? And I don't need to even ask you, do I need to ask this question? Yeah, z divided by y. So key to any solving any equation is identifying this structure. But this structure is already obvious. Isn't it right? This is z. This is x. This is y, right? Isn't that right? So then,
yeah,
think about it. We know our target future value, our target future amount. This is what you want to have in 10 years, right? And the interest, 10 years means you know this, right? Right? You know n. and interest rate is known. You know this too, right? So y is known, right? X is the unknown. So how do you solve for p? P is the unknown. Of course, then it's z divided by x is z divided by y. So p is, you can find the principal. In other words, 1 plus r raised to n. Oh my God, that one. Where's my cursor? There you go. Okay, so this way you can find your principal. In other words, how much you have to put in there. But then, when you solve this equation for principal, right, that means your future value is known, rate is known, n is known. In that case, this principal is called the present value, because that's exactly what it is valued at the present. In other words, the future value, that's what that future value is valued at, what that future value is worth today. So it's called present value. So then solving that, and ignore m for now because it's 1, it's annual compounding anyway. So all you need to do is future value divided by 1 plus r raised to n. That's going to give you exactly 10,000, right? But what about if we have, if the compounding frequency is 4? We just need to make adjustment for that. So all I need to do is, right, divided by 1 plus EPR divided by M raised to T times N. There you go. Then you get exactly 10,000. And also, you can simply copy and paste it into, A14. And then A14 has changed. The formula has changed. And again, it's not going to affect anything because anyway, M is 1. 1 is, just 1 does nothing. It's just, innocuous, right? So we can also do it like this model where we have, more periodic rates. Two more columns, one for periodic rate, the other one for n. So don't leave it like this. A good housekeeping is always crucial. So I'm gonna put a thick border line around it. Okay. Next question is, how do we solve for? So for example, your target future value is 30K, and in 5 years you want to have $30,000. You have $10,000 today. Okay, then and if assuming compounding is just annual here, okay, and this one, assuming compounding is annual, So what should be the interest rate? So we solve this equation for, in other words, we'll need to solve this equation for R, right? Which is, actually, if you solve the equation for R, it's nothing new. Basically, again, R is inside this parenthesis, so, and it's locked by this N, which is the padlock. So we need to, we cannot isolate R directly, so we need to isolate whatever, 1 plus R to the N first. So whatever needs to be done first. So this is, first we isolate whatever we can, and then we isolate. Then how do we open up this? Well, this is nothing new. Remember, this is nothing new. This is what we did at the beginning. Remember, the first thing you encountered was geometric average, right? This is basically how you find the geometric average. We talked about, some, law of the exponents, right? Properties of exponent, right? Remember this? X squared, if x squared is y, how do we solve for x? We have to take, a square root of x, right? And the square root is 1 over 2 is another notation for square root. And this is 2 and 1 over 2 cancel out, because that's the, product of, power of a product. Right? It's actually this one, power of power, right? A raised to B raised to C is A to raised to B times C, right? So that's why they cancel out, right? Okay, that cancels out. So it becomes X, but then it's an equation. That means, whatever you do to one side of the equal sign, you must do the same to the other side of the equal sign. So I took a square root in the left-hand side, so I must take the square root on the right-hand side too, right? And you do it that way, for any power, right? Any n, right? Does everyone remember this? Because this is what we did at the beginning of the semester.
Yes.
Huh? Someone?
Yes.
Okay, thank you. Thank you for that confirmation. All righty. So now it's easy. This is something we already know, right? This is something we already know. It's nothing new. The other one is something new, but we'll get there. So here, so what do we do? To find the rate, all we need to do is, okay, F3 over PV raised to 1 over N. N is here T because, it's annual compounding. We don't have any, it doesn't change, over 5 years, because it's annual compounding. The actual number of compounding is still the same thing. N is the same thing as T in this case. And I want to click it in, but it's in T, that N is in C18. I want to click it in, but since this formula is hanging over that cell, I cannot click it in. So then what do? I can simply type in that, right? Then you'll have to type it in, -1, right? Okay. There you go. What did you get? Oh yeah, this is an APR is 24. I mean, think about it, tripling your money, tripling your investment, tripling your investment in 5 years. Tripling, what kind of return does it require? It requires like almost 25% return, right? Annual return. Okay. Now, let's think about it's the same. Oh. Okay. It's the same scenario, but now what's the difference? What has been different? What has been made different? It's the compounding frequency. Now the compounding frequency is 4. That means quarterly compounding. Quarterly compounding. So if n is 4, all we need to do is we need to make a little adjustment to our formula. Okay, so then obviously we know n is not 5; it's going to be 20 because over 5 years there will be 20 compoundings. That's the only. So what goes in here is this over this raised to 1 over t times m. That's going to give you n. T is in C20 times m is in D20. Since the formula is hanging above it, I had to manually type it in. And then why the parenthesis? Why the parenthesis to t times m? Well, it's because if you don't do that, then 1 will be divided first by C20, and then the result will be multiplied by D20. So then it's going to be a totally different thing. That's why you have, and by putting them in the parentheses, then this will be done first. Okay, and then minus 1. Okay, and hit enter. And then you find, oh, well, something weird. This is something weird. Why? I mean, how can it be a 5.65? I mean, excuse me.
Bless you.
Thank you.
You're welcome.
Excuse me. So, oh well, when compounding frequency is just once a year, it took almost 25%. But just because compounding frequency is quarterly, so it takes drastically smaller interest to take you triple your money over 5. No. First of all, what is wrong here? This is not annual rate. What you solved for is periodic rate. This is like every quarter. Quarterly, it takes 5.65%. So what do you need to do? So this is the quarterly rate. So what you need to do is you multiply it by m, which is in D20. Because think about it, annual rate divided by 4 was the quarterly rate. Then to convert it back to annual rate, then you must do quarterly rate times 4. Then it's going to be annual rate. Okay. Then think about it. Oh, this is why. Remember when we did, ROI, when we talked about geometric average. Geometric average is much smaller than simple average. That means because of compounding, right? You don't need that much interest rate to take you to the same future value. And also that also explains, because there's more compoundings going on here. Think about it. When compounding is quarterly, then there will be 20 compoundings going on, as opposed to annual compounding, then where there will be only 5 compoundings. So with more compoundings, with smaller APR, you can get the same result, right? Does that make sense? With smaller APR, you can get me. So that's what, that's how we find the rate. First of all, you understand that looking at this formula, right? Looking at this formula, there are 4 variables: FV, P, R, and N. Since there are 4 variables, there can be 4 unknowns. 4 unknowns. Of course, you can't have all 4 unknowns all at the same time. You cannot solve it. There should be only one unknown, and all the other variables must be known. So when FV is the unknown, that means all the other all the other variables must be known. P, R, and N must be known. If P is the unknown, then FV, R, and N must be known. If R is the unknown, the others must be known. If N is the unknown, then the others must be known. You understand? So we have solved this equation already for 3 variables: FV, P, and R, right? Now, so the last thing remaining is, where am I? The last one remaining is the N. I'm gonna have to talk about it tomorrow. We're out of time, so we're gonna call it a day here. I'm gonna stop, and I'm calling it a day. And you guys have a good rest of the evening, and I will see you tomorrow. Okay?
Thank you.
All right, you're welcome. I'll stay safe, and I'll see you tomorrow. Stop.